Hi, this project is from Railtech Multitech, Dr. Rangarajan, Dr. Savitla Engineering College, from the Department of Electronics and Communication Engineering. Our project title is Intervehicular Communication using Rectangular Split Ring Resonator Antenna. Presented by R. Akilan, Prasant P. Revant R. and guided by Mrs. Kavita S. BEME PhD. Our contents are this: objectives, introduction, literature survey, existing system, workflow, proposed method, advantages, conclusion, future scope, reference. Our introduction: split ring resonator is an artificially produced structure common to a metamaterial. Metamaterial is an artificially engineered material designed to induce customized properties. The conventional split ring resonator unit cells was composed of two rectangular coplanar metallic rings. Rectangular SRR structure on the substrate is investigated with finite element method based on software HFSS tool. Our objective is to design an implementation of split ring resonator for intervehicular communication. To overcome dedication short range communication, that is DSRC. To achieve maximum radiation pattern using a FR4 substrate with a rectangular SRR antenna. To avoid traffic accidents and show real-time warning system of the vehicle. This is our literature survey where we refer from the authors Nagarjuna, Tanikonda Anil Kumar, Yalavotra, Priyanka, Tuluri Satish from the year of 2019 and from Nurada Singh Sanjay Kumar Sharma in the year of 2020. This is our existing system. The design and analysis of hexagonal SRR antenna for 5.9 GHz. The antenna is capable of producing linearly polarized radiation. An hexagonal SRR antenna used for vehicle to infrastructure communication. Combining the rectangular bands with EVT structure, the bandwidth of the antenna has been increased by 39.63% and the size of antenna reduced by 22.38% compared to the antenna without EVG. Workflow. Our first process is to design and stimulate the antenna in the ANSYS computerized software for designing and testing. Our second process is to implementing boundary conditions and excitation of locket port. Our third process is to apply output variables and parameters for the antenna design. Our fourth and final process is to finally testing and integration of rectangular SRR antenna. This is our proposed system. The design and analysis of rectangular SRR antenna for 11 GHz in X-band. The antenna is capable of long distance communication. The antenna can communication with other vehicle which is at long distance. The maximum is achieved at 11 GHz in X-band, which increases the bandwidth and radiation for communication. This is our proposed model where two split resonators are induced above the field. This is our parameters: height, width of the antenna substrate, height and width of outer ring, height and width of an inner ring, height and width of an antenna field. Next at the very step, our adding boundaries to master 1 and master 2. These are the results of our proposed project. These are our results of an proposed antenna model. Real and imaginary permittivity is dipped in the 11 GHz and permittivity also increased. Real and imaginary permittivity. The real characteristic of a substrate called permittivity, often known as the electric constant, defines how quickly it may get polarized by the electric field. As per our design, the permittivity of the antenna is maximum at 11 GHz. This helps for long distance range communication. The output variable is used to generate a graph that illustrates the relationship between imaginary and real permittivity. This is our S parameter plot where our S parameter is dipped at 11 GHz. S parameters. The behavior of two-port network or device is described by collection of complex integrators called S parameters. often referred to as scattering parameters. The ratio of the reflected wave to the incident wave at port 1 is called reflection coefficient and is denoted by S11. SRR is intended to be used as a resonator for intervehicular communication at 11 GHz. It would be advantageous to have a high value of S11, the reflection coefficient at the port 1, in order to reflect some frequencies while rejecting others. Low values of S11 and S21 would like to be preferable in the scenario to reduce energy transfer between ports and improve the SRR resonance property. This is post-processing of a real and imaginary plot, where our output variable of plot 1 shows to dip at 11 GHz. This is post-processing of real and imaginary Z. In SRR antenna, the real and imaginary components of the input impedance Z are important parameters that determine the antenna's performance. Post-processing of these components can help improve the antenna's impedance, matching and radiation efficiency. Post-processing the real imaginary parts of the received signal can improve accuracy and reliability of the received signal, which is critical in intervehicular communication applications. This can be achieved by adjusting antenna's geometry or by using reflector or the director to enhance the radiation in a particular direction. These are the advantages of our project. Our first, avoid traffic accidents and produce safe journey to the users. They are light in weight and smaller in dimension and lower in price. Moreover, the SRR antenna is a metamaterial which has a unique customized property. This is our conclusion of our project. By using 11 GHz for long distance communication, vehicles can easily find the object for a distance itself. This helps the driver to drive safely with precautions. By placing the antenna at the center of the vehicle, it can radiate at a maximum distance. Thank you.